Alright, so we're going to start out. I want you guys to do this whole first page here. So you're doing 2 all the way through 6, okay? So together with your partners, go ahead and do 2 through 6. Go ahead. Okay, so number 2, ask me about the vertical change. Everybody show me vertical change with your finger. Show me vertical change with your finger. This would be vertical change, right? Up and down. So an up and down motion would be vertical change. So if I'm trying to find the vertical change between A and B. So when I'm finding slope, because that's what this is getting at, when I'm finding slope from a graph, a couple things I want to clue you in on. Make sure you pick good points, okay? Everybody look up at my screen really quick. If I'm trying to find slope, and I pick this point right here, y'all see where my dot is? If I pick this point right here, you may say the x value there is 2.2. You may say the x value is 2.3. You may say it's 2.25, okay? That's open for interpretation. I don't want to pick a point like that. Even if I pick this point here that's on x equals 2, well, I don't know if that's y equals 2.7, 2.8, 2.75. Again, open for interpretation. They picked good points for you, obviously. So you want to make sure that you're picking good points when you are required to pick the actual points, all right? All right, so, and the second thing is, I don't want to see you do this. So everybody look at my screen again. Counting the vertical change, I don't want to see you go 1, 2, 3, 4. 4 is not the vertical change, okay? The first A point is the starting point. I move up 1, 2, 3. Okay, going from A to C. Oh, I went too far. My vertical change would be up 1, 2, 3, 4, 5, 6. Going from C to D, it's up 3. Okay, so my vertical changes, A to B would be 3, A to C is 6, C to D is 3. And then I also want the horizontal change, okay? So the horizontal change left to right. Going from A to B, I'm going over 1, 2, 3, 4. From A to C, it looks like I'm going 1, 2, 3, 4, 5, 6, 7, 8. And from C to D, another 4. Okay? So the horizontal change is 4, 8, and 4. Then it tells me, then it uses the word slope. And you guys are probably, hopefully, familiar with slope. What's a way that you've heard slope described in the past? Okay, Caleb, were you about to say something? Rise over run. Okay, that's the way that most of you have heard it described before. And rise would be the same thing as the vertical change, right? Up and down change. And run would be the same as the horizontal change or the left and right change. Okay, so when I'm finding slope, rise over run, or the change in y, so between A and B it would be 3 over my horizontal change of 4. Do not ever, 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 ever write slope as a decimal. Okay? Under no circumstances should you write slope as a decimal. Always leave it a fraction, okay? Between A and C, it's a little bit bigger. It's 6 over my run of 8. Second thing about slope, you always want to make sure and simplify, right? So how could I simplify this here? What could divide into 8 or 6 and 8 both? 2. So if I divide a 2 out of both of those, then I'm left with a final answer of 3/4. Okay, so always make sure you reduce. And then lastly, between C and D, I have a rise of 3 over my run of 4. So what do you notice about all the slopes between the 2 points? Yes, Sam? The ratio is always the same, or the slope is exactly the same, right? So the slope is always going to be exactly the same from any 2 points that are on the same line. And that's what your answer should have been, something along those lines for number 6. You know, if the slope between points is the same, you know you have a straight line, okay? All right, so this is exactly how we need to find slope from a graph. A couple things that I want to clue you in on before we move on. It's always easiest to go left to right when you're counting slope, okay? If you're counting up, what kind of number is that? Positive. If you're counting down, it's a negative number. So you might have a line that looks like this, okay, in which you'd have to count down and over. This down would be some kind of negative number. My suggestion is always go left to right, because if you do at any point count left, that's also a negative number. Okay, but generally kids forget that one. So if you always are counting left or right, that's always a positive number. Then you just have to worry about up or down, which you guys are pretty good at. Okay. All right, so let's go ahead and flip over to the next page. And now this page is looking at the formula for slope. Okay, so using a formula. So maybe we don't have a graph, but we can use a formula. So let's look at two different points than we've looked at before. Let's look at B and D. So finding the slope between B and D. So from the previous page, it's kind of hard for me to flip back and forth between pages, but can somebody give me the coordinates for B on the previous page? 0, 2. Actually, let's do B and C instead of B and D. Thank you. And can somebody give me the coordinates for C? 4, 5. Okay, perfect. So 0, 2, and 4 and 5. So then putting these in, my first point will be 0, 2. My second point will be 4, 5. All right, so I want you to take that information, and I want you to answer B all the way through F. So answer B all the way through F together with your partners. Go ahead. Okay, so again, everybody show me vertical change with your finger or arm or whatever. What kind of values are these? These are Y's, right? Up and down values would be Y values. So what are the Y values that I'm working with here? 2 and 5. Okay, so 2 and 5 are my coordinates that relate to the vertical change. Everybody show me horizontal change with your finger. Good, side to side, what kind of values are those? X values. So I'm using 0 and 4. All right, so let's determine change. What's another word for change in math? Difference. That's a good mathematical word. Okay, so difference. I want to think about it as difference, okay? So what is the change or the difference between 0 and 2? To go from 0 to 2, sorry. Going 2, right? You're moving 2 units. What about the horizontal change? How do I get from 4 to 5? It's not a trick question. Okay, I'm just moving 1 unit, right? So then calculating my slope, my vertical change over my horizontal change would be 2 over 1, which is just 2. Okay? All right, so I want you to take this same exact concept, and now I want you to apply that same exact concept to number 11. Okay, so instead of numbers in the ordered pairs, it gives you these two random ordered pairs, x1, y1, and x2, y2. So you're going to do that, and you're going to do the same thing. You're going to calculate the vertical change, or the change in y, and then you're going to calculate the horizontal change, or the change in x, and then you're going to write the formula for slope. Okay? So no numbers involved here, just using those two arbitrary points to come up with the formula for slope. So try to get through this with your partners, okay? Go ahead. Okay, so what values here are involved in my vertical change? Y1 and Y2, right? My two Y values, just like we did up above. So how do I find the change or the difference between the two Y values? What operation is that? Subtraction, right? So I'm going to subtract the two Y values. So I take Y1 minus Y2. Or you could do Y2 minus Y1. It honestly does not matter. It won't ever make a difference. Okay, and then let's do the same thing horizontally. Okay, so horizontally, I'm doing the same thing with the x values. Again, I want to find the change or the difference. So this time I'm taking x1 minus x2, or you could do it the other way, x2 minus x1. All right, and then how do I write, or how do I calculate slope again? What's the quick and easy way that you guys know how to do it? Rise over run, right? So rise, again, has to deal with the vertical change. So I could do y1 minus y2 over run, which is the change in x, x1 minus x2. Okay, here is my disclaimer and warning in the same sentence, okay? Here's my disclaimer. It does not matter which y you start with, or which y you start with on top, or which x you start with on bottom. What does matter is that it has to be the same. So if I start with y1 on top, I have to start with x1 on bottom. If consequently, and here's my or, I start with y2 on top, so I do y2 minus y1, what has to be on bottom? x2 minus x1. Okay, so that's my disclaimer and warning at the same time. It doesn't matter, but it does. Okay, it doesn't matter which one you start with, but whatever you start with on top, you have to start with the same one on bottom. This is what I don't want to see. Okay, I do not under any circumstances want to see, y2 minus y1, x1 minus x2. That is completely and totally wrong, or vice versa with y1 first and x2 on bottom. Okay, that's what I absolutely do not want to see. Okay, all right, so that's my spiel on slope. We have some special cases to look at, so let's flip, or no. We're not to the special cases yet. I want you to do, how much time do we have? We're doing okay on time. Let's do 16, 17, 18, and 19. Okay, so 16 through 19. That's what you're doing together with your partners. Go ahead. Okay. All right, so 16 wants me to find the change in x and change in y. I'm going to take it a step further and go ahead and just find slope. Okay, one thing you guys need to realize is you need to start associating the letter M with slope. Oops, need my pen. Okay, M always represents slope. Here is my helpful hint when you're finding slope, because sometimes we struggle with negatives, and that's okay. I just want to kind of proactively try to take care of it, okay? So if you struggle with negatives, you might want to start doing this as you find slope. Just start by writing down your fraction bar and two minus signs. That way you never forget them. Then just plug your numbers in where they go. So what goes on top? What values? X's or Y's? Y's. So I'm sticking -2 and -7 on top. Since I started with -2 on top, I need to start with 7 on bottom, so 7 and 9. The reason I like to do it this way is because then I am absolutely positive to see all of the double negatives. Okay, like I have -2 minus a -7. So anytime I see that minus a negative, I change it to plus a positive. Now my slope M, -2 plus 7 is 5. 7 minus 9 is -2 on bottom, so 5 over -2. And realize -5 over 2 is the exact same answer. Okay, it doesn't matter where that negative is. All right, number 7. It says Connor determines the slope between -2, 4 and 3, -3 by calculating 4 minus a -3 over -2 minus 3. April determines the slope by calculating it opposite. Explain whose reasoning is correct. Alex. Okay, can somebody tell me why April's wrong? What did April do? Yep.
I don't think she had the -3, it was just a regular 3 minus -2.
Well, what's the regular 3 and minus 2 and -2? What values are those? If you look back to the ordered pairs. Travis?
-2 is x, -3 is y.
Okay, so what did she put on top? She put x's on top, right? Okay, so she put x's on top. So that's probably where April went wrong. Okay, 18. When given a table, can I find slope? I sure hope you can. Okay. All I'm doing instead of finding two ordered pairs is I'm just pulling two ordered pairs out of the table. So you can honestly pick any of them that you want. I'll just pick these last two to reiterate this negative point. Okay, I go ahead and write M equals, I put my fraction bar and two minus signs down so I don't forget those negatives. And then I stick my y's on top, 1 and -1. And since I started with 1 on top, I need to start with 9 on bottom, so 9 and 11. So anytime I see that minus a negative, I change it to plus a positive. 1 plus 1 is 2 on top. 9 minus 11 is -2 on bottom. 2 divided by negative 2 is m equals negative 1. So I have a slope of negative 1 for number 18. And lastly, number 19. Are any questions before I move on to 19? Okay, I need to zoom in here so you won't be able to see the rest. Okay, so I need to zoom in nice and close so I can pick good points. So good points, I can pick any two of the following. This one looks good, this one looks good, this one looks good, this one looks good, and this one up in the top looks good. Okay, any of those two would be good points to pick. I will just pick, how about these two? Okay, so I'll pick the two in the blue, and now I calculate my right. Again, I'm going to go left to right. Up is a positive number, so up 1, 2 over 1. So 2 over 1 would be my slope. My m equals 2. Okay, can I get a comfort level so far? Okay. All right, let's look at special cases. Okay, let's look at special cases on the next page. All right, we're skipping 5. Oops. Skipping 5. Let's look at 6. And 7 for that matter. Okay, so let's just start with 6. Actually, let me zoom in because it's going to be kind of hard to see if I don't. All right, so 6. I pick any 2 points on the line. So I'll just pick this one and this one. What is my rise between those 2 points? 0, right? I'm not rising anything between those 2 points. And what my run on my particular 2 points is 2. It doesn't really matter what your run is. What is 0 divided by anything? 0, right? Just think about 0 pizza divided by among 2 people. Everybody's going to get 0 pizza, right? So anytime you have a horizontal line, the slope is going to be 0. All right, here's a different way for me to help you remember. So everybody hold up your arm in a horizontal line. Okay? So if you have this kind of road, your fist of your other hand is going to represent the car. Put the car on the road. Put it in neutral. Y'all know what neutral means? Yeah. Good. Put it in neutral. How fast is the car going to go?
Neutral. 0.
It's going to go 0 miles per hour, right? If you stick it in neutral on a completely horizontal road, it's not going anywhere. All right. All right, let's look at a vertical line. Okay, so this first graph on the vertical line. Again, pick 2 points. Pick these 2.
Oh, I know this one.
What is my rise between these 2 points? 2. What is my run between these 2 points? This time my 0 is on bottom. Okay. Do me a favor really quick. Actually, let's do the pizza first, okay? So I have 2 pizzas. I divide them among 0 people. How much pizza does everybody get?
None. 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 There's no people.
None, or there's no people?
There's no people.
There's no people. So does that question make any sense at all?
No.
Does it make sense for me to ask a question, how much pizza does each person get if there are no people? It doesn't make any sense. Okay? Do me a second favor. Type in on your calculator 2 divided by 0.
0.
Type in 2 divided by 0.
Error.
Yeah, you guys that thought you were so smart just saying 0, you were wrong, right? So if you type it in on your calculator, it says error or divide by 0 error or something along those lines. Okay? Meaning you can't divide by 0. Okay? No, do not ever say no slope. Don't do it. Okay? Don't say no slope, because no slope really could imply this, or it could also imply 0, right? Because a lot of people say 0 is the same as no, so you want to be careful with saying no slope. If you ever put no slope on a test, I'm going to assume you don't know which one's which, and I'm going to give you no credit. Okay?
How people think 0 means no? Because no is kind of negative.
Because you don't have any apples, you have 0 apples.
Oh, so you have none.
Okay, so we call this undefined. Okay, undefined. You can't divide by 0. Anytime you divide by 0, it's undefined. You can also just put UND period if you want to, as an abbreviation. Okay, again, make your road, except this time it's going to be a vertical road.
That doesn't, you can't drive up that then.
Okay, put your car on the road. Put it in neutral. What happens?
It's fall.
You're not going to drive on this road, right? It's going to crash and burn like crazy.
Once if you're going in neutral, then no way you're going to drive.
Okay, there's no way you're going to drive. So you can't drive on that road. It's undefined. If you put it on a horizontal road, you're not going anywhere. Okay, that's my way to kind of help you. All right, so that's special cases. Anytime you see a horizontal line, 0 slope. Anytime you see a vertical line, undefined slope. All right, one last page. How many of you, well, no, you wouldn't have gone through this. Guess how many job applications I saw and job descriptions posted when I was trying to find a job that was looking for a professional slope finder?
0.
Yeah, none, right? There are no professional slope finders in this world, okay? So what is my point of teaching you this? Well, there are lots of real-world applications that deal with any kind of slant, also known as slope, that we need to be able to calculate a slope, apply it to some kind of real-world situation, and understand how slope can help our understanding in these particular situations, okay? So let's look at one of those examples here. It says, Margaret went to the lumber yard to buy supplies to build a wheelchair ramp. She knows that she will need several pieces of wood. Each piece of wood costs $3. So it says model with mathematics. Write a function f of x for the total cost. So that's our total. F of x is going to be our total cost. Equals the wood pieces if Margot buys X pieces of wood. So how does she spend money? How is she getting a bill here? What's she buy? Wood for how much? $3 a piece. So $3 times how many pieces of wood is she buying? Come on, guys. How many pieces of wood is she buying? X. Is she spending her money any other way? No. So this is a pretty simple equation, okay? So let's say our pieces of wood, I generally pick 1, 2, 3, 4, 5. Doesn't really matter what you pick there. Those are just easiest for me to work with. So let's start there. I want you now to do the rest of B. So you're going to fill in the rest of the table of data. You're going to graph your data. And then I would also like you to do C, D, and E on the next page. So you're going to take this and you're going to go all the way through E on the next page together with your partners. Go ahead. Okay, so filling in my table of data, if I buy 0 pieces of wood, I'm going to be charged $0, I hope. Then if I buy 1 piece, I'm just plugging in my numbers 3, 6, 9, 12, 15. Okay, graphing here. Okay, I have 0, 0, 1, 3. Goes up just like that. Okay, let's talk about finding the slope from a graph, because the next question asks us to find slope. If I find slope from the graph, is it accurate that my slope is up 1 over a half?
No.
1 over 0.5. Why not? Which would be 2. FYI. 1 divided by half would be 2. Oh, the tick marks are going up how much? 3. So I have a lot of kids when we get to this quiz and test on a problem similar to this. If the tick marks are not going up by 1, they'll get this wrong. So make sure you're very, very careful. My suggestion on a problem like this is don't mess with the graph after you graph it. Just do your formula because that's the easiest. Alright, so just a little FYI, make sure you're careful there. So let's go to C. It says, what's the slope of the line that you graphed? I would pick 2 points and do it similar to how we did the try these problems on the other page. I would pick any of the 2 ordered pairs is fine. I'll just pick 1, 3 and 3, 9. Okay. So I know that to find my slope, M, I put my fraction bar in 2 minus signs, stick my y's on top. So that would be 3 and 9. Since I led with the y value of 3, I have to lead with the x value of 1 down on bottom, so 1 minus 3. So 3 minus 9 is a negative 6. 1 minus 3 on bottom is a negative 2. Negative 6 divided by negative 2 is a positive 3, so I have a slope of 3. Okay, and then last but not least, other page, E. E is probably the absolute most important problem on this entire note sheet. I know you know how to find slope. Okay? Yeah, you may make mistakes every now and then, so does everybody else in the whole entire world. Okay? You know how to find slope. If you're careful, you can find slope pretty easily every time. What I care about is, can you apply it? Can you take the slope of 3 and now apply it to this problem? What does that mean? Every slope is an action-reaction type of number. So what is the action-reaction that's involved here? Travis, you want to give a shot?
That if she buys more pieces of wood, and the price of it goes up by 3.
Good, that's perfect. That's the action-reaction. So I would say for every piece of wood she buys, there's the action. What's the reaction? How does the 3 go into play here? And Travis said the bill goes up by $3 or something along those lines. The bill okay, it's important that when we write out this explanation that we use action-reaction and that we're specific to the slope. Please do not write on a question like this. Please don't just put the more wood she buys, the more the bill is. Okay, you have to be specific to the slope. You have to always bring it back to the slope of 3. For every piece of wood she buys, the bill goes up by $3 specifically. Okay? All right, comfort level on a problem like this where we have to actually take slope and apply it. Everybody please. Okay, good. Alrighty. The rest of the time is yours to work. Okay, so you can grab your homework off of Canvas. Go ahead.